Alright, you guys, so this is just a short video to review with you the ideas of domain and range, what you might see, and then how we notate domain and range in interval notation. So, first of all, if we look at this graph on the left, it's obviously a line. Now the red dots that are on the graph are only to indicate that that's the x-intercept and y-intercept. But you can see that this line continues and it appears to run off the graph. So when I talked about the idea of sometimes with technology we don't have the arrows at the end, this is what I'm talking about. It seems to go to the edge of the grid and just, bump into that border. And likewise that happens here, and that happens again down here. So we're going to assume that this graph was made with technology and that they intend for it to continue on. So we could draw those arrows in there. So therefore, as we consider domain, we're thinking about, well, what numbers on this graph, and I'm sorry if this is in the way, but as we look at it, does it seem to continue going from to the right, to the right, and how does it seem to continue going to the left? Well, we assume that it's going to continue on to the right forever. It's going to continue on to the left forever. So that is domain. Okay? So the domain of this is going to the left forever and to the right forever. So we're going to say that our domain goes on the left to negative infinity, and it goes on the right to infinity. So this is our domain. Domain indicating left and right. So you have to apologize for the sloppiness here. I have to write without putting my hand down, so it's pretty sloppy. Okay, so then the range is all about where is it going up and down. So for the range, we look at this and it appears that it's going to continue going up as it goes to the right. It's going to continue going down as it goes to the left, so it's going up forever and right forever. So the range of this function is also down forever, so to negative infinity, up forever, so to infinity. So the range is also from negative to positive infinity. We use parentheses because we can't contain infinity. We can't say it goes to infinity like that's a number. Infinity is a concept. It's just, going forever and ever and ever in that direction. So there's no way to contain it. So we use parentheses, not the bracket. Okay, looking over here at this one, and again, it's running off the edge of the graph, so we can assume that it means for arrows to be there. And so going from left to right, well, this is a parabola, and as it goes down, it's also going to the left forever. So thinking about our domain, we're going to keep putting in x values, and it's going to keep spitting out y values. And so the domain of this function is, again, it's going off to the left forever. And it's going to continue, as I put in those x numbers, it's going to continue going down on both sides. So it's going down forever. And even if it maybe stopped for some reason, like if this had a restriction, it would still continue down forever. So it's going to the left forever, it's going to the right forever. That's those x numbers that we're putting in. That's the domain, those x numbers. Left forever, right forever. Okay? Now the range is a little different on this one because it's going up to 4, but that's as far up as it goes. So for up, it's going to 4. Now it's going to 4, so we include 4 in our domain because there's definitely a point at negative 2, 4. But it's not going to go up any higher than 4. But going down, it's going to go down and down and down. As we keep putting in more x numbers, it's going to continue to go down on both the left and the right. So for our range, first we say how far down it's going, so we go from least to greatest. It's going down to negative infinity, but then it's going up to 4. And we include 4 because there is a point at negative 2, 4, but that means we put a bracket. So the parentheses means not including. We can't include infinity because there's no actual number there. It's a concept. And a bracket means including. Okay? So we're including 4. Now, if, for example, well, we'll see it, I think, on the next screen, but if, for example, for some crazy reason, somebody had put an open circle at 4, instead of it just being a nice smooth curve, they had put that little circle there, then that would mean, well, up to 4, but not including 4, so we would have used a parentheses down here instead of using the bracket. Okay? All right, so here's just some more examples. Here on the left, we have a discrete graph, so instead of it being all connected dots, they're all disconnected. So now when we list our domain, we just list the exact points that we have, because that's all we know. So we might start by writing what we call the relation, which is the list of points. So we have a point at 1, 3, and I just work my way from left to right, and we have a point at 2, 1. We have a point at 3, negative 1. We have a point at 4, 2, a point at 5, 0, and a point at 6, 6. So this is called the relationship. And now to write the domain from that, our domain would be a list of all the x numbers. And notice that this time we use set notation. We use this little brace to say, you know, this is the set of specific numbers. It's not an interval. So we have 1, 2, 3, 4, 5, and 6. Madison Dean. Madison Dean is forever held in this video. Okay, because I'm at school. So, and our range is all the resulting y numbers, which would be, usually we go least to greatest, so the smallest one is negative 1, and then we have 0, and then we have 2, and we have, or excuse me, we have 1, it left out 1. We have 1, we have 2, and we have 3. So that's our domain and range when we have these distinct set of points. Oh, and I left out 6. How could I leave out our current 6? I need to fix that. I have a correction. So here we go. I'll change that to 6 and then put my new bracket. Okay. So then over here, where we have this graph is not a function. And it's not a function because for all of the x values greater than 0, there are 2 outputs. So for example, for the input value of 4, there's an output of 2, and there's an output of negative 2. So therefore, this is a graph of a relationship, but not of a function. We can still state its domain and its range. So the domain, again, goes from left to right. You know, how far does it go left? How far does it go right? What numbers are included? So, whoops. We want to look and see, erase for me. There we go. Over here on the left, it goes to 0, and it includes 0 because the curve is going right through the origin. So we're going to put a brace to say including 0, and that's my smallest number. But then here on the right it's going infinitely, and this one has our nice arrows, so we're sure of it. And so it's going to the left forever, or excuse me, that's my right. It's going to the right forever, so it's going off to infinity, and we put parentheses on the side brace on the left, parentheses on the right. Now the range, as we look over here, it's going to continue going down infinitely. It's going to continue going up infinitely, so it's going from negative infinity to positive infinity for the range. So how far down will it go? How far up will it go? It will go infinitely in both directions. And then the last little example I have here is of a function, but we're only looking at a limited part of it. So this function, the domain, simply is going from here at 0 to down here at 7. We have our nice dots. That's nice that they put those there, and they're nice solid dots. So we're saying we're including 0 and we're including 7. So our domain for this function, on the left, we are going to 0 and including 0. On the right, we're going to 7 and including 7. So that's our domain, how far it goes on the left to how far it goes on the right. And we use our interval notation because there's a nice smooth curve in there. We're including all the numbers from 0 to 7. This is actually connected down here at 7. It just kind of didn't look like it because the 7 got in the way. Okay, and so for our range, be careful. We're not looking from the first dot at the first dot and the last dot to see where they are. We're looking at how high does it go. Well, it goes up here to 4, and 4 would be included because it's touching 4. And it goes down to -2 because, again, it's touching -2. So our range, at the bottom we go to and include -2. At the top we go to and include 4. And then that's the end of it. That's as far as it goes. But I do want to address, what if this dot over here on one side, what if that dot was an open circle, not a closed circle? So I'll see if I can kind of make that look like an open circle. So we'll say at 7, they had an open circle instead of a closed circle. Well, it would not affect the range. The range would still go from down here at -4 to up here at positive, or down, -2 to 4. So it would not have affected the range. But if we had that, the domain would still start at 0 over here on the right and include 0 because there's a solid dot over there. On the left, I'm sorry, I keep saying my directions wrong. I'm bad about that. But here on the right, it would go up to 7, but it wouldn't include 7. So 7 would be a boundary, but not an included boundary. So instead of having a bracket, we would have a parentheses. And so it would change the domain to look like that. All right, so that's been a little review of domain and range and our notation. I hope this helps.